All right, we're back with some ROM hacking. It's been about a day for me, and as I threatened, I did a little thinking. I even wrote out my thoughts a little bit in this brainstorming chart. So yeah, let's see what avenues we might pursue here. We have our annotated trace stuff that we kind of worked on in the last video, and that allowed us to break on gamepad input. Now we could, because we now are able to break on gamepad. I mean, we have the trace of what happens when you press a button, but a trace isn't as good as stepping through the code, because in a trace you can't actually inspect, the contents of the registers and what is in the memory accessed. You don't see that during the trace. I don't see an option to enable that. So the ability to actually step through it with the debugger, we can actually see what values are being, shuffled around. And that could allow us to do things like map what each of the buttons turn out to be after it's been all processed and everything. And we could also kind of follow the trail of the button data and see where it gets to the place where you actually start doing, the game calculations. So that's one kind of avenue we could explore. Another thing here that I added is we could chart the groups. What does that mean? Well, we did the differential between the action trace and the idle trace, and we found that there's about 100 groups of instructions there. Most of them are tiny groups, so there's actually probably way fewer considerable large groups. And we could go through each of those and basically try to figure out what they do. Now, this mark subroutines idea, that's kind of related to this in that I'd like to start in the code. So it's tricky here. If we look at this trace, this isn't the same as a dump of the assembly code of the program, right? This is just the addresses in the order they're visited. But we would like to have a static dump of the addresses in the order in which they are in memory. And then we can see the separate subroutines. And so I'd like to have a static disassembly of all the game code. And then I'd like to go through, and as I walk through the trace and try to figure out what it's doing, when I figure out what some section of code is doing, I can then find that section of code in a static disassembly and mark the subroutine, label it, say, okay, this is subroutine called, I don't know, roll a dice or whatever. And then whenever I encounter that subroutine again, I would be able to quickly identify what it's doing. So in a trace, and then what I could do is, even once I've marked the subroutines in a static trace, I'll know what range of addresses belong to what subroutine. And then when I'm post-processing a trace, I could even add a label to say what subroutine this section of code belongs to. That'll just make my life easier. And as I figure out more subroutines and mark them, there are fewer and fewer question marks in the landscape, and so it makes it easier to navigate, is basically. And I think one tool we might even be able to use for that is called Ghidra. I looked up briefly, and it does support 68K, so we might be able to use that in this capacity. And I don't know, maybe it even has an ability to automatically detect subroutines and kind of section them off based on stack frame creation or whatever. I don't know how that works yet on the 68K, but I assume that they have some kind of stack frame deal going on. At least they have to save registers or whatever at the beginning and end of a subroutine. So we'll see how that all works out. Now, the last thing I thought of is, so any game, you look it up on GameFAQs, it'll have cheat codes. So Game Genie cheats, and maybe how to hack a save game in an emulator. And what that is basically is someone found out addresses where certain variables, statistics, settings live, and they tell you those addresses and what the values mean. So when you set a value at that address, it means you can walk through a wall, or it means you can set your gold to 9999 or whatever. So if we could find cheats that correspond to attributes that are used in combat, maybe I could then search a trace and see where they access that address. And that'll quickly allow me to identify places where the game combat logic is being done. Or I could set a breakpoint on memory access of those places and then automatically break when they are accessing that, which means they're probably doing some game logic stuff. So we could try to find or navigate our way through those variables using some things that people have marked out in, cheat guides. And I think that's what I'm going to actually do today. All right, so on GameFAQs, there is a save game hacking guide. Okay, how to convert decimal to hexadecimal. Okay, so here we go. So we have locations where player data is stored. Player 3, player 4, so character data, right? And yeah, we can see here strength, intelligence, wisdom. Okay. So I guess the easiest one to just see would be player's name. We could look that up and see the string value directly in the memory viewer. So let's boot up. All right, here we are with our default party again. Stop. Go away. Let's just hide in a corner here somewhere. Okay, so if we go to inventory, we can see our character name. So the first character's name is Anthony. So if I now break, and let's see if we can find. So we can go into memory B5A6. So debug, we go new memory window, and we go to B5A6. And we see definitely does not contain the string Anthony. All right. So that's not useful at all. These values aren't correct for us. What we could do, but though while we're here, we could try to search for the string Anthony in the memory, kind of work it backwards. Because that should be in there, right? It's not like they're going to encode it in a weird way. So here, memory debugger commands, we have a find. Search through memory for a sequence of data. So, we could search through all the memory for the string Anthony. So let's do that. How do we do? So we could do find. We're just going to go from 0 to FFFFFF, which is the full memory space of the CPU. And the string we want to do is Anthony. Bam. Okay, so we found... All right, we found it in a lot of places, which is a little surprising. You wouldn't think it would be stored in that many places. Now we can see here that there are very high addresses that store it, lots of those. And then there are a few low addresses that are also storing this, 251A. None of these seem very close to this, though. Let's check the memory map of the Genesis if we can find one. All right, here we see a 6800 memory map. So from 0 to basically 3F is cartridge memory. So when you plug the cartridge in, you get all the stuff on the cartridge maps to those addresses. And up here, we see that the very high FF range, you got 64K of the RAM that is hooked up to the CPU. And everything from C to FF is reserved. So this is interesting. So we can see that these 3 hits are in the cartridge. The low 4 nibbles here are all the same. It's just these ones here, 0, 1, 3, that are different. We also see that there are 2 hits in the RAM, but then there's a bunch of other hits that are in reserved memory space. So this already tells me from what I know about, digital logic systems. The address lines, the top, I don't know how many address lines, maybe like 4 address lines are not connected at all. So we're aliasing. So probably this is the exact same RAM, physical RAM location as this, as this, as this, as this. All these different addresses are all actually just aliasing to the same place in RAM. So I think we have 2 locations in RAM where this string exists. And there are 3 places in the ROM where it exists, but they are very likely also aliases. So I would expect to see Anthony in the ROM because it's a default party. So this is hard coded in the ROM, and then if you choose the default party, it will be copied into the save wherever that is. What this means is I think we have 2 that we're dealing with. We could do a little test though. We're all about science here. So if we create a custom party and we give them some dumb names, when we search for it, we should not see it in the ROM, only in the RAM. So I'm going to do that. All right, so here I am. I'm creating a new party, and we'll just do chill. We'll make a string that we're pretty sure is not going to exist already in the ROM. Chill X ass. All right, and I'll just feel like the rest of the party members with just random. All right, here's our party. Okay, so we got the oh boys, lock the doors, close the windows, turn out the lights. The Mormons are coming. Anyways, yeah. So if I go here, we can see. Yeah, here is my party. We got Chill X ass. Okay, so now we want to search for this. Oh, let's see what we get. All right, so again, we find, yeah, we got this stuff all in the FF addresses. But look, we did our search. There is nothing in the cartridge ROM. So this is only in our RAM, which we would expect. And I would expect these to all be the same. So now we have 2. So now I'm wondering if we change one of them, what happens? Okay, so let's start with 5C. I'm just going to let's restart this. Exit. Let me exit. Yeah. Let me exit. Okay, so we're back in the map here. So if I go to FF5C00, what should we see? I mean, we should see the name in there, right? FF5C00. Yeah, and there's my name, Chillass. Now, I should be able to just change this. 4. So now we're Didillass. And then I should be able to see that in my inventory. When I go into here, inventory. It still says Chillass. Okay. That's strange. Well, I mean, there's 2 of them. The other one might be. Oh, wait a minute. Okay, interesting. It wrote over my Didillass in here, or turn it back to Chillass. Okay. So, I mean, this could. I don't know why, but this could be like a cache. So hopefully the other address is the source of truth, and if we edit that one, then it'll work. I don't know. Okay, well, let's go to the other one. Let's get out of here. Get out of here. Okay, we're gonna break. So we'll go FF912E. Okay, so there's also Chillass X. So let's go 4444 Didillass. Now, if we go to the other one here, FF5C00, still says Chillass X. Okay, now let's run. Let's go into our inventory. Yeah, and now this one, which is the cache, got written from the value that I stored in the other address, which is FF912E. Yeah. And now you see here, Didillax ass. There you go. Okay, so this is telling us, yeah, I mean, I guess it makes sense. I don't know if you don't think about it too much. This one is the source of truth, and this one just gets like copied whenever you go into the inventory and it's used in there for whatever reason. I don't know why there's 2 of them in there. Maybe we'll discover that along the way, but that's the way it is. So now my next question is, okay, so we found out where the name is stored in memory. Now let's go back to our guide here. So this is obviously a different address, but maybe the relative positioning is the same. So if we find how many bytes the strength is after the beginning of the player name, and then we apply that offset to our addresses in RAM, maybe we'll be able to change the strength. What do you think? We give it a shot. So we have to calculate. So B5 F6 minus B5A6. B5A6 equals exactly 50 hex. So if we add 50 hex to FF912E, FF912E equals FF917E. Okay, so we're going to get out of this. Get out of here. We're going to do this one. We're going to FF917E. So FF917E. 7E. All right. OC OE. So OC is 12, and I think his strength was actually 12, so this is very promising. So let's set that to 18, which would be 1, 2. And then let's go into here, run it. No, don't break. Why did I hit the break button? There we go, run it. Let's go back into our menu, moment of truth. Yeah, and now the dude, he's buff, 18 strength. All right, so we have the ability now. We know where all the things are. As long as we can find where the name starts, we can navigate around to all the other character attributes. This is good intel. I'm just going to create a little table here, keep track of all these addresses so I don't have to keep finding them and calculating them. So we need the HP. We're going to just do a little offset math where current HP, max HP, so A6 to CB. So that's 25 hex, and then we add that to FF912E. That's equal to FF9153. Okay, so let's put that in here. 9153. Okay, and then we should just copy this, paste that in here, and we see 6, which is, yeah, his HP is 6 out of 6. Alright, and if I were to, let me just exit out of here again. I'm not sure if editing those in the, while we're in the inventory is a good idea. So let's say his HP to 3, and let's, yeah. Oh, you don't even have to break, maybe. Let's try it out here. Inventory. And now he's a 3 out of 6. Okay, so what I'm going to do is I'm going to find the addresses for the HP of all these characters. And then I'm going to set breakpoints on those addresses. And I am going to get into combat, and then I'm going to see when an enemy hits me, which might take a while. But when that happens, if it actually stops at the breakpoint. Alright, now I'm wishing that I gave them a little more better names than A, B, C, D, E, F, because those might have more hits than what I would like to see. But we'll see. We gotta find the addresses of all the names here. Although, when you think about it, they might actually just be, like, I might also be able to calculate the offset from the first character to second character, and it's likely going to be the same in memory as it is in this, because the reason why these addresses don't line up is I think these are offsets into the save file for a specific emulator, not offsets into memory. But because those derive from memory, the relative positioning is likely to be the same. So let's just give it a shot. We'll subtract this one from this one. So we add 96 hex to our base, and we get FF91C4. All right, let's do this one. I wonder if I can just copy that. Yeah, I can. Just put that in there. Boom. AB. Okay, so that is easy. That makes my life easier. Let's just put that in here. I'll do that for the other ones. I won't assume that it's the offset is 9.6 for all of them, although it almost certainly is. But we'll double check. We'll fill this table out here. We'll fill out the addresses for HP for each of these. And when I come back, we will try that breakpoint stuff. All right, I got my table filled out here. Let us do a little journeying, get into a battle, and see if we can't trap some memory accesses. Okay, that didn't take very long at all. Let's see here. Now, I don't know how often it's going to read from HP. It might read from it every frame to do something for all I know. So I think putting a breakpoint on write would be a safer bet. Now, let's look into this guy here. All right, so it looks like it is part of the watchpoint debugger commands, WP set. And let's just see some examples here. So we can do RW to specify read or write. We put the address, we put the length. And we can also put a condition in here, but I don't worry about the condition. All right, so I want to set watch points for all of these addresses for writes, just a single byte is I think the way we want to do it. Let me do that. Okay, so we'll come up here. Let's see if we can get a, this is a break watch point. Debug. No, okay. New break watch points. Let's see, options. Turn on watch points. Okay, we are in watch point mode right now. And let us do WP. What is this? WP set. What is this? WPI set. I don't understand, but we just do WP set, and I think that'll be fine. WP set. The address will be, where's my table? We want 1 byte, and we want it for write only. There we go. Address 5353, type write. All right, let's do these for the other ones. All right, so I got all these in here now. I saw something interesting though. After I got into this fight, looking at the memory space of the 4th character, we see bore after that there. So it looks like this memory space that is used by our characters also will store the stats of the enemies that you are currently fighting afterwards. So that's interesting. Might be able to use that at some point. But anyways, for right now, these watch points should be good, and we should hopefully get a break. XO. I guess this is all enabled. So we should get a break whenever one of our characters gets hit. Possibly killed? I don't know. These guys are pretty squishy, I think. Anyways, let's just see where we can take this. So we're gonna run, and yeah, go ahead. Oh, I got up. Yeah, good. I broke already, so that was apparently a hit. Maybe. Let's just let it go and see if it's actually hit. So I did get a breakpoint here. Stopped at watch point 1, reading to FE. So there's a chance it might write even when it's not changing the HP, like it'll just write the same value that exists, but I doubt it. I think this is probably a hit. So let's run. Wait a minute, it just did it again. So it wrote to it a second time? Man, it's writing to this memory address like a lot of times. Well, 2 times so far, which is more than I expected. It got 5 damage. So it's interesting that it actually writes to it twice. It's doing it again. it's writing to the memory address again, writing 0. It's writing FE. So first it writes like a huge number, 254. Then it writes a 1. Now it's writing a 0. So I think maybe this guy's just dead. Now it's writing FF. What is going on with this algorithm? Run. And writing a 0. And I should just you press F5 at this point. There is a button for this. F5. Writing FF. Writing 0. Writing FF. Writing 0. Maybe it's using the hit points as like a flag to determine like when the character is blinking. That's very interesting. That's a very strange, but I mean this doesn't change here. It's very odd. Oh, he's dead. Anyways, he's dead, so rip bozo. All right, so that was like a special case of when your ass dies. Hopefully, I would just like to, not see. I just want to see one where you don't die, maybe, because that seems a little different. But also, it's very strange that it's, it goes down to 1 and then it goes to 0. I don't know. I don't know what's going on here. This is very interesting, very intriguing. How do I skip turns? I think I just pressed this button here. This button. This button. Oh well, gotta focus the window first. Go, skip, go, skip, skip, skip. All right, so we broke again. So we got another hit. Let's press F5. Now 6 damage. And now he has 1 left. So if you don't die, it doesn't do the weird shit, which is good. I would very much rather see, the case. Oh, it's interesting. So this sequence of blinking here, this is happening at a much different address than this address here, which is probably, this is where the logic lives. Yeah, so 13D98, 13D98. Yeah, okay. Interesting. Stopped at breakpoint, watch point 3. Yeah, so it only writes once if it's just a hit. Oh, he's goosed him. All right, I'm back with the default party, and I've added a watch point here reading for the strength of the first character. And so now what I want to do is I want to do an attack and see if it's actually reading the strength when it's doing the attack. It should if it's following the rules, because strength is used to determine, your chance of hitting, I guess. So we should skip you. Here you go. All right. So let's see. Oh, I skipped him. Okay, whoopsie doodle. And I skipped him again. We'll get to him. All right, here we go. So it should be this one. And if I press it, it should break. All right, that's a little interesting what we just saw there. We saw a little animation and then it broke. So it actually does a little animation before it does the hit calculation. All right, it's a good thing that I didn't try to search my action trace for the address of the strength stat, because I wouldn't have found it. What it's doing here is it's doing like indexing from a base address, adding an offset, and using that as, I think, the strength, because it's loading this into D1, and we look in D1, and it contains 18, which seems like the strength of a fighter. So yeah, it does like a relative offset from this A3, which I guess is the beginning of the character. Now we know that from the beginning of the character's name to strength is 50 hex. So I guess the beginning of the character is 2 bytes before its name. Interesting. But yeah, A3, I guess, contains the base address of the character's attributes, and then they use offsets from that to determine, loading the different stats. But yeah, I mean, we got like a ton of good intel from this little test here. First, we know that there's those 2 addresses where they store the attributes, and it is, the one that you expect is the one that they're actually referencing in combat. They're not referencing that other one that we had that keeps getting overwritten when you enter the inventory screen. So that one isn't being referenced, which is good to know. And like I said, we also learned that it doesn't do all the calculation ahead of time. It actually does some animation and then some calculation. So that's a little bit of a monkey wrench, because I'd like to ignore as much as possible the code relating to animation. But it looks like we might have to step over that before we can get to calculation sometimes. So interesting stuff here. Now, this is gonna be calculation, but there might have been more loading of pertinent values up here that I don't see. So I might want to figure out a better place to break. I can't actually scroll up any higher than this. So this is where it would be nice to have a static decompilation. I don't know if there's like a command to load more up here, but yeah, a static decompilation would be nice to analyze this, find the start and stop of the routine. But we can kind of trace through here and see what's going on. I don't understand this. Like, this is load effective address, right? This is loading an address into an address register, but I don't understand this semicolon here. What is this syntax? I mean, I imagine this is whatever's in PC, and then we subtract this from it, but then do we load from that address in memory into here? And then what is this? I don't understand. What the PC is 14312. So that could be, this semicolon here could just be the disassembler saying, hey, this is, when you do this calculation, this is what you get. Now, is it loading the value stored at this address into A0, or is it loading this address into A0? I guess we step and we could find out. But let me just do a little quick calculation here. So PC is currently 14312, and then if we subtract 642, that is equal to 13CDO, 13CD2. Did I enter in something wrong? 14312. So it's like incredibly close to this value, but not quite. I mean, this minus might be adding a little sauce to it. I don't know how this works. I'm just going to be honest with you. Well, there was this one for CD2. Yeah. So it's 2 more than, I don't know. So is this value what gets loaded into A0? Let's step and find out. We can single step with, I believe, F11. So if I do F11 here, where's A0? So it's currently nothing. And 13CD2. So I guess this is basically just the disassembler's way of telling you this is what this evaluates to. And I don't understand this offsetting, but this isn't loading the value at memory. This is just loading this address into here. And I guess the parentheses are just a way of showing that it's an address. I don't know. But anyways, so we load the address, relative address in memory, and then we add this plus D1. So I believe, so I'm thinking this is a table, right? And the table is stored, in memory with the code, basically. And so we look up into that table using the strength value that we got from D1. So if I look at this address here, A0. So 13CD2 is the beginning of perhaps that lookup table. And we are seeing garbage. And then it's 0, 0, 0, 0, 1, 1, 1, 2, 2, 2, 3, 3, 3, 3, 3, 3, 3. Now, this makes sense to me, because I know a little bit about the rules of D&D, and I know that generally these stats, they apply bonuses when you exceed a certain threshold. So you can't have a strength stat less than a certain amount. So if this was 0, 1, 2, 3, 4, 5, 6, 7, 8. So this is kind of telling us, indicating 9 is probably the minimum strength you can have. And at that strength level, you get no bonus. But as your strength goes up, you get a little bonuses. And that's what this is doing. This is loading a bonus and adding it to D0, which is building up some kind of thing that's going to be used to determine whether you hit or not. All right, we are starting to decode this. This is very interesting. But I'm going to take a little break at this point. Maybe do a little off-screen playing around with this. And yeah, when I come back, maybe I'll have some findings for you.